Alright, now I'm looking at maximum geometry rotations. And so I start with two maximum geometry circles, and these are just approximated. They're not obviously exactly perfectly aligned. And I started with, and I said the center point of these circles would be 0, 0. And so I knew that this point from a circle of radius 4 was going to be 0.44, and this point I determined for a circle radius 2 would be 0.22. And so I decided I was going to move each of these 1/8 of the circle. And so my initial distance was 2 units, and I can find that by doing 4 minus 2 or 4 minus 2, and that always will equal a distance of 2. So I came up with my new points at 0, 4 and 0, 2. And so I wanted to find the distance between these points. Now I also found that this distance was 2, because 4 minus 2 is still 2. Even though both of these have a 0 for their x-coordinate, and the distance between 0 and 0 is 0, in maximum geometry we only look at the maximum distance, so either the x or the y, and in this case it is the y distance that is the maximum distance between these 2 points. And so even when I go a strange amount of the circle, like in EAS, distance wasn't preserved unless you went a full quarter of a circle. Even when I go 1/8 of a circle, I found distance was still preserved. And so that really leads me to believe that a rotation in maximum geometry is an isometry. So then similarly, if I change my points to variables, like I did here, so I changed this to point BB, point CB, CA, AA, and this is point CC, I can see that my distance will stay the same. So this distance now, instead of being 2, is A minus B, and this distance is also A minus B, even though the distance between C and C is 0. Again, just look at the maximum coordinate, which in this case is the y. And so that's how I'm able to see, even when using variables, that this will always be an isometry.